Hi, I'm Alex, and in this short video I'll give you an introduction to battery energy storage systems for commercial buildings. Until quite recently, battery energy systems in buildings were only used for things like emergency lighting or uninterruptible power supplies for servers. The cost and performance of battery systems has started to fall, however, and some businesses are now installing them for other purposes. Apart from emergency lighting and UPS applications, there are two main ways in which you can use battery systems in your building. The first way is to reduce peak electricity charges and costs. If you have the type of energy contract where you pay a higher rate for your electricity at peak times, it could be worth considering battery storage. If you charge up the battery using grid electricity when it's at its cheapest, and then use the stored energy later in the day or even the next day when electricity costs are high again, you can sometimes save energy and help reduce your true carbon emissions. Using batteries in this way is sometimes called load shifting. The other application for batteries, which is becoming more popular, is where you've already got a source of renewable energy generation such as solar PV, and you regularly produce more electricity than you use. Without a battery, any surplus generation is exported to the grid, and you can sometimes get a small payment for it. But if you install a battery system, you can use more of the solar generated electricity yourself. Therefore, you don't have to buy as much electricity from the grid. You effectively increase your self-consumption of solar generated power. The electricity you would otherwise have to purchase costs a lot more than the value of the exported electricity, so that's where the savings can be made. If you don't already have solar PV, it's quite unlikely that a battery energy storage system will stack up commercially, as battery costs are still quite high. But if you do have solar, or could potentially install it, it may be worth investigating battery storage a little further. Unfortunately, there's no easy way to work out what kind of return you might get from your investment, and some detailed calculations are required to work out whether it's likely to be worthwhile. You need to start with a detailed understanding of your electricity consumption. By analysing your half-hourly electricity consumption data over a whole year, you can see how much your consumption varies depending on the time of day, the day of the week, and the time of year. It's then possible to compare this to your solar PV generation, allowing you to identify when you have a surplus of electricity that could be stored. It's more or less essential to have half-hourly data. Here's some half-hourly data from a warehouse building which operates 24 hours a day. The data has been expressed graphically using colours to show the electricity consumption for each half-hourly period. The days of the year run left to right, and the hours of each day run top to bottom, from midnight to midnight again, in half-hourly segments. The green areas of the plot represent periods of very low electricity consumption, and the red areas represent the peaks of consumption. So in this example, the warehouse has good natural lighting during the daytime, so it only needs the lights on from dusk until dawn again. And they're only using electricity for lighting, so as you'd expect, the loads are highest at night, and the need for lighting reduces during the summer. The half-hourly data has given us a clear picture of how much electricity is used and at what times. Imagine the warehouse owner installed a good-sized solar PV array on the building. It would only generate power during the day, in other words, when it's not needed. Here's the forecasted electricity generation profile for a solar PV array. You can mathematically combine the historical half-hourly electricity consumption data with the forecasted solar PV generation data to see how much electricity could be exported. In this example, most of the solar PV generation would be exported to the grid, and the business wouldn't get a lot of benefit from having solar. This is where a battery system could come in. It could be charged mainly from the solar array during the day and used to power the lights at night, thereby reducing the amount of electricity that needs to be purchased. Depending on your electricity contract, it may also be beneficial to arrange the control system of the battery so that it provides most of its power during peak times when the electricity is at its most expensive. Having looked at the concept of battery energy storage systems, it's worth going into a bit more detail. Let's start with some of the technology and jargon that's commonly used. Behind the meter and front of meter batteries. The battery energy storage systems we have been talking about here are sometimes called behind the meter batteries. This is to distinguish them from grid-scale battery storage plants. They tend to be operated by the distribution network operators or National Grid themselves. The storage capacity. Manufacturers usually quote the storage capacity of their systems in kilowatt hours. For example, a commercial battery energy storage system might have a storage capacity of, say, 400 kilowatt hours. The power rating. Battery energy storage systems can't supply an unlimited amount of power to the loads in your building. They're actually limited by the battery chemistry and their power electronic converters. The power rating of a battery system is usually given in kilowatts or sometimes in kVA. Some manufacturers describe their battery system by the power rating and the discharge duration. For example, a 100 kilowatt 4-hour battery would have a storage capacity of 400 kilowatt hours and a power rating of 100 kilowatts. Most commercially available battery systems are modular, so it's possible to configure bigger or smaller battery systems from the basic building blocks offered by the manufacturers. AC and DC coupled systems. When battery systems are combined with solar PV, you can have the two separate systems kept completely separate. That would be known as an AC coupled system. The power from the solar PV system is first converted to AC, and that's used to charge the battery through the battery system charger. In a DC coupled system, you can have a hybrid inverter, which can charge the battery from the DC power generated by the solar PV system, and this avoids some of the conversion losses that you would get with an AC coupled system. There are actually pros and cons to both approaches. Financial models can be very sensitive to system sizing, so it's really important to make a thorough assessment. We can use modelling algorithms to analyse building energy consumption profiles and solar PV generation profiles, whilst taking into account any time of day import and export tariffs. The algorithms are used to determine the most appropriate battery storage capacity so as to optimise the financial value of a battery system. Modern lithium-based batteries require little in the way of maintenance, but they must be designed, installed and commissioned properly and regularly monitored to ensure they remain efficient and, most importantly, safe. If the worst should happen, lithium fires are extremely difficult to put out, so it's vital that proper fire risk assessments are undertaken and the right control measures are put in place. It's quite common for battery systems to be located outside of occupied buildings as an additional fire safety precaution. And you should also think about security and, if necessary, vehicle impact protection if you're planning to locate the battery system in a car park, for example. Commercially available systems have sophisticated BMS, battery management systems, and these ensure the batteries are safely managed and do not overheat during charging or discharging. The BMS system also helps to ensure the batteries are never discharged completely, as this can have a damaging effect on them. I hope you found this useful. You can find more information about battery energy storage systems by downloading our fact sheet, or if you're interested in other technologies, we have more videos available. Thanks for watching.